Oh, hello there. In this video, we are graphing a polynomial. I am aware that it's a quadratic trinomial, but we are graphing this using the approach I use on polynomials in general. In the next video, we will tweak this one just a smidge and turn it into a cubic polynomial instead by multiplying through by an x. So for a little compare-contrast situation, please, at the end of this video, click through for the next one so you can really just kind of see the evolution of this particular example. I don't know what he's looking at, but it's not the notebook. He's not being a focused student right now. What do you want? Oh, there's a cookie. You want this? Yeah. Okay. Here you go. You want this? All right. Can you, ready? Speak. Speak. A little louder. Speak. Thank you. What a good boy. Okay, let's get into it. For fuller details of the procedure I like to use, as well as what local behavior is, as I've said 100 times already, please watch the first video in this playlist, the graphing polynomial playlist, y equals x to the third minus 4x. I go into all the details in that video, and I've been kind of adding little things here and there throughout different videos in the playlist. So first step we are going to look at is E for end behavior. So the end behavior is based on the leading term. In this case, the leading term is a positive x squared. That means that our end behavior is up and up. The fact that it is a positive leading term gives us that up right there. And the fact that it is even gives us that up right there. If you write it with words, you write the words up and up. I avoid using a plus sign. After that, we are going to fully factor everything. So E to F. So we are going to factor this. Now, if you need to know how to factor, I have a whole playlist. This is not the time or place to learn how to factor. X, what multiplies to give you 30, adds to give you 11, 5 and 6, of course, and they are both positive in this case. And it was G of X in the beginning. Let's make this snappy. I think he wants another cookie. He's like crying at me. All right, next is Z for zero product property. So we're going to set each factor equal to 0. X plus 5 equals 0. That means X equals negative 5. That's one X intercept. X plus 6 equals 0. That means X equals, oh my gosh, if you hear him, I'm so sorry. Negative 6, that's another intercept. So after that, A is for axes. Well, I have those prepared for us right over here. That is done and ready to go. Next thing is we're going to be P and L, plot and label. So plot the points, but also label the local behavior. So I'm plotting, I'm going to have negative 5 and negative 6. So I have 1, 2, 3, 4. Here's negative 5. And here's negative 6. Okay, I'm only labeling the numbers I care about. I don't label my y-axis, but I'm also going to label them with their local behavior, which I figure out by going back up to my factored form. These are both to the first power on the outside of the factored form, so they're both going to be linear local behavior, linear and linear. So as I plot, I'll also label, so it's right there and right there. I'm also going to label them with an L for my linear behavior at each of those places. And I'm also, before I get into the last step, which is G, right? G, which is to graph. I'm also going to tack in, stick in my end behavior arrows, which we said were up and up. What's our insurance policy? What are we talking about with our insurance? In order to ensure fewer mistakes, more likely an accurate graph and a correct answer, you start graphing. Again, what is it? Do you know the insurance policy? We start by using the right side of the end behavior and we work our way backwards to the left. So I know that this is pointing up. You're more likely to have this right. Okay, correct on the right. And we're going to work our way here. We're going to pass through linearly. Got a curve. It's got to be smooth and curvy, no pointed edges. And then here, this will locally pass through quite linearly as well. So locally, it should look pretty straight. So if I only zoom in and look at those parts, it should be pretty straight. So here we have a sketch of our polynomial. Good enough, depending on your scale, your stretch of your axis and your spacing. You could look a little bit different, but it should be more or less a curved, rounded parabola type of graph. up and up on both ends. X-intercepts are at -6 and -5, cutting through. And when you zoom in, it should be pretty straight. That's the end of it. So hope you feel smarter. Click through for the next one where we boost this up, evolve this into a cubing. Thumbs up for puppies and polynomials. Look at the playlist. Click for the next video. I have to take care of this furry baby over here. And I will see you next time. Bye.